Okay, LeetCode problem 1438. Longest continuous subarray with absolute difference less than or equal to the limit. So given an array of integers, nums, and an integer limit, return the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to the limit. So basically that means any subarray where the maximum and minimum elements in that subarray, the difference between them cannot be more than the limit, and we return the max subarray, like the max length subarray, where we can validate that constraint. So to do this, I'm going to initialize an answer to 0 and our left pointer to 0. And then I'm also going to create two monotonic decreasing and increasing queues because we'll need to store the max and minimum elements of our subarrays, and a monotonic queue is an easy way to do both of those. So do let increasing equal queue and let decreasing. Okay, so we have that. So I'm going to initiate a loop, a for loop through the numbers list so we can iterate from the beginning to the end. So I'll do for let right, call it this right pointer, 0 right, less than nums.length, just to iterate through. And we need to check if the next number to add is either greater or is either less than the previous number in the increasing queue, therefore we need to pop that previous, or if the next number is greater than the previous number in the decreasing queue, because we need to pop it as well, because it doesn't follow our monotonic queue pattern. So while we have something in increasing, and while our next number to add is less than our increasing one. Yeah, so while the next number to add is less than our increasing variable, our last increasing number, obviously we need to pop it and remove it from that list. So I'll just do the same thing, decreasing length, nums I. This time, if the next number to add is greater than the previous number we've added to our decreasing queue, obviously that doesn't work, so we need to pop off until we find a previous number in decreasing that is greater than this num. So decreasing length. I'll do decreasing pop. Okay, and then when we've gotten our max and min values in our first subarrays, we can just go ahead and add, or once we finish that constraint of not adding something to it, if it's greater than or less than given the current queue, we can just push. We can just add it. So do decreasing push. Okay. So this just adds the next number that validates our queues in a monotonic fashion, either decreasing or increasing. So from here, we need to check while the first value in the decreasing, so so it'd be the max value, because if you're decreasing, your max value is at the beginning. So the first value in the decreasing, so I'm going to check if we break our constraint. So increasing 0. So if our max value minus our min value is greater than our limit, therefore we break that constraint. I need to check if the decreasing value is equal to the number we need to remove and the leftmost pointer from our numbers array. Therefore, if we remove that, let's see, decreasing left. So I remove that first value, therefore we get closer to being within our limit. So, okay, if increasing, left. So if increasing, we need to increasing, we just shift those initial values. And then after that, we increment left by 1, so we shrink our window, which gets rid of, see, like this basically checks if we're breaking our limit, then we need to remove the leftmost value in our queues because they would be breaking that limit, whichever one matches the current left pointer. So I'll do that. And then we need to update our answer. Do answer right minus left plus 1. And right minus left plus 1 is just the formula for calculating the length of a sliding window. And here our cases, our right is to the next, is this latest index of the number we've wanted to add or added. And then our left is the leftmost point of our window, plus 1. So I'll just return answer, and we'll see if this works. The one solution, I'm used to I actually named it. Not looked, okay, yeah, no, okay, it should be right. And it works.